Hi sir, so I'll kickstart our FOS video presentation by introducing our group members. I'm Xuan and the members of this group are Albert Pang, Eng Zheng Yu and also Tye Khan Wei. The topic of our presentation is real-time operating systems versus multiprocessor operating systems. I'll start off with the contents of our presentation. In this presentation, we will cover the intro, background, and also the detailed discussion of real-time and multiprocessor operating systems. We will be discussing on what are these two operating systems about, the key features and applications of these two OS, and how do they work. Furthermore, we will cover the types of real-time and multiprocessor OS, their popular software, and the comparison between them as well as their pros and cons. So I'll now start off with the intro. With the advancements of technology, almost all of the electronic devices are equipped with operating systems that allow programs to be installed and executed for various tasks. This enables humans in various sectors to have more efficient workflows so that they can focus on more complex problems. Anyways, when you talk about computer operating systems, there are two OS that are more prominent in this area, which are real-time operating systems, which is RTOS, and also multiprocessor operating systems, which is MPOS. These two are specialized systems cater to the demands of specific computing environments, providing efficient and reliable solutions for critical tasks. In this presentation, we will dive deep into the world of real-time and multiprocessor operating systems. So I'll then continue with what are they all about. Real-time operating systems are specialized operating systems designed to handle time-sensitive tasks and applications. Unlike general-purpose operating systems, real-time OS prioritizes tasks based on their urgency and ensures that critical operations are executed within specific time constraints. It is crucial in domains where timing and responsiveness are critical, such as aerospace, automotive, medical devices, and so on. With features such as precise task scheduling and task prioritization, real-time operating system offers deterministic behavior and seamless coordination among tasks. As for multiprocessor operating systems, they are operating systems that are used to efficiently boost the performance of multiple processors within a single computer system. It is extremely important in maximizing system performance, throughput, and scalability of multi-core processors. By distributing tasks among multiple processors and allowing for parallel execution, MPOS enhances overall system performance and facilitates workload balancing. It also provides mechanisms for resource allocation and load balancing to enable seamless coordinations among CPUs. I'll now continue with the key features of real-time operating systems. One of the main key features of real-time operating systems is that it is deterministic. It prioritizes tasks based on their urgency and guarantees a maximum response time for critical tasks. Next, they focus on task prioritization. This allows critically urgent tasks to interrupt less important ones with minimal latency. Critical tasks with higher priorities will be executed first, ensuring that essential operations are not delayed by lower priority tasks. Furthermore, real-time operating systems often incorporates fault tolerance mechanisms. These mechanisms enable the system to ensure the safety and integrity of the critical systems by using error handling techniques. Last but not least, they also provides mechanisms for precise task scheduling, resource allocation, and synchronization to meet strict timing requirements. It ensures that critical operations such as aerospace are executed within specific time constraints. So that's all from me. I'll now pass it on to Albert to continue with the key features of multiprocessor operating systems.
Hi sir, I'm Albert and I will continue with the key features of multiprocessor operating systems, or in short MPOS. MPOS brings enhanced performance and scalability for systems with multiple processors. At the same time, they support workload distribution to split the computing tasks between the processors. MPOS optimizes resource allocation to ensure all processors run at their best performance. It does have shared memory to communicate between the various processes. MPOS can incorporate fault tolerance mechanisms to maintain system reliability and handle process failures. I will continue with the application of both RTOS and MPOS. One sector for the use of RTOS is aerospace and avionics. The OS ensures precise timing and responsiveness in critical processes such as avionics, instruments, and flight control systems. Another area RTOS is used is the automotive sector. RTOS enables real-time response and coordination for the various systems, such as in the electronic control unit or ECU, as well as airbag control, which are critical functions. RTOS is also used for medical devices to ensure timely delivery of medical treatments and data processing in critical healthcare applications. Common devices include patient monitors as well as defibrillators. Telecommunication and gaming consoles do make use of RTOS for handling real-time data transfer between devices and has reliability built in for reducing delay and communication distortion. Meanwhile, some key areas for MPOS are in servers and data centers. And in database systems where there is heavy workload, MPOS allows the workload to be distributed between multiple processes. MPOS makes servers more efficient and increase data retrieval speed for databases with the support of parallel query execution. MPOS is also used for high-performance computing, where executing intensive processing is needed for the purposes such as in scientific research and weather forecasting. Lastly, MPOS is used for multimedia and gaming, for applications such as video editing and 3D rendering, but it does depend on the software itself whether it is optimized for multi-core processing. And I will be continuing with how RTOS and MPOS works. For RTOS, it provides a fixed environment that ensures tasks are completed in a time-critical manner. It is designed to meet strict timing to ensure system stability. Task management is implemented to assign various tasks for the processor. Interrupt handling, which allows for critical tasks to be run with minimal delay. Context switching, which allows the current state of the task to be saved and then restored later when the processor continues with the task. Timers and clocks are implemented to facilitate time-based operations and trigger periodic events at precise intervals to ensure task completion in a timely manner. In RTOS, it generally has microkernel architecture with monolithic kernel. This architecture runs quickly and offers high performance. For MPOS, it allows multiple CPUs that are linked together to perform computing in parallel for quicker execution. In MPOS, tasks share system resources, which include system memory and cache memory. MPOS does require a motherboard capable of accommodating multiple processors for efficient processing. Processors themselves also become integral components of MPOS to be able to distribute workloads, manage threads and processes, efficiently handle memory, and enable parallel computing to harness all the system's processing power. I will now pass it to Xuan to discuss the various types of RTOS and MPOS.
Hi sir, I'm Zheng Yu, and now I'm going to talk about the types of real-time and multiprocessor operating systems. I'll start off the real-time OS first. Okay, the first type of real-time OS is hard real-time operating system. Hard RTOSs are known for their ability to guarantee all critical tasks can be completed within the specified deadlines. A hard RTOS is intended to provide reliable response times, typically within tens of milliseconds. Examples of hard RTOS include VxWorks, QNX, and FreeRTOS. The next type of real-time OS is soft real-time OS. It is as opposed to hard RTOS. It does not handle deadlines as strictly as them. While they are still prioritized critical tasks, soft RTOS allow occasional deadlines misses as long as they are infrequent and do not lead to catastrophic failures. Examples of soft RTOS are Windows CE, Linux with PrimeRT, Patch, and some variants of FreeRTOS. Besides, there is a firm real-time operating system which lies between hard and soft RTOS. The system failing to meet a deadline will not entirely shut it down while using firm RTOS. However, these minor errors could result in a degradation in the final product's quality. Example of firm RTOS includes VRTX and RT Linux. Last but not least, another type of real-time OS operating system is distributed real-time OS. They are made of real-time applications that are dispersed across several linked devices. Examples of distributed RTOS are Pike OS and VxWorks Cert Edition. I will now continue with the types of multiprocessor operating system. One of the common types of MPOS is symmetric MPOS. All processors are of the same type and have equal access to the main memory as well as the input or output devices in a symmetric operating system. The operating system treats all processors equally and can dynamically schedule tasks on any available processor in the system. One of its downsides is that it will be quite costly for users. Next, there is asymmetric multiprocessing OS. In contrast to symmetric OS, an asymmetric OS system consists of multiple processors of different types or capabilities. For example, asymmetric operating systems have often used in embedded systems where different processors handle specific tasks. The third type of multiprocessors OS is non-uniform memory access MPOS. It is a specific architectural design where multiple processors are connected to different memory banks, resulting in varying memory access times for different processors. It aims to minimize memory access latencies and manage local data more efficiently. I will then continue with the popular software of these two OSs. The first popular software of real-time OS is FreeRTOS. This RTOS is an open source that is known for its efficient and lightweight design. It is developed by Amazon Web Services. Next, they have VxWorks. It is developed by Wind River System and supports application deployment in containers. Besides, they also have QNX. It is developed by BlackBerry, designed to work in an embedded system. Last but not least, Microium OS, also known as Microcontroller Operating System. It is a microprocessor kernel that uses priority-based preemption, and it's mostly developed using C programming language. And I'll now continue with the software of multiprocessor OS. Firstly, multiprocessor OS has Linux. It is a commonly used open source operating system that supports multiprocessing and can operate on many architectures. Next, they also have Unix. It is a multi-user and multitasking operating system designed for flexibility and adaptability. Some of the Unix-based operating systems include Solaris, AIX, and HPUX. Last but not least, Microsoft Windows Server is also multiprocessor OS. It mainly provides features for loading balancing, resource management, and task scheduling. It's very popular because it allows users to navigate it easily by having a simple GUI. That's all for me. I'll pass it on to Khan Wei to talk about the comparison between real-time and multiprocessor operating system. Thank you.
Hi sir, I'm Khan Wei, and now I will continue with the comparison between real-time and multiprocessor operating systems. There are quite a few differences between these two operating systems. We will first start with their purposes. Real-time operating systems' main purpose is to meet strict timing requirements of real-time applications, where multi-processor operating system. The primary purpose is to utilize multiple processors or cores at the same time efficiently to improve overall system performance. Next, we will talk about their task management. Real-time operating systems allows the creation of multiple tasks and to execute them in sequence based on priorities to meet deadlines. The focus is to ensure timely execution of time-critical tasks. On the other hand, for multiprocessor operating systems, they focus on managing tasks that are distributed across multiple processors. It aims to balance the load efficiently among processors by distributing the tasks between them evenly. Furthermore, real-time operating systems provide IPC mechanisms to enable communication between tasks, mostly to take note on minimizing communication latency. Whereas for multiprocessor operating systems, they support IPC to aid communication between processors running on different processors. Last but not least, real-time operating system is more lightweight and less complex, while multi-processor operating system is more complex as it needs to manage more than one CPU. Now, I will continue with the pros and cons of real-time and multi-processor operating system. As these two operating systems are able to give us many advantages, there will be some disadvantages alongside it too. So, we will be discussing about all the advantages and disadvantages about these two operating systems. We will start with real-time operating system. Real-time operating system has memory allocation that involves allocating and delocating memory tasks and processes in a way that maximizes resource utilization. For example, static memory allocation, heap management, and memory partitioning. Besides that, one of real-time operating system advantage is that it can be embedded. This results in a less complex operating system and a physically smaller software, allowing it to be more portable and efficient. Next, real-time operating system does not make error mistakes. Users are able to test, retest, and confirm that system perfectly completes the planned task with a specially designed system. It is designed with features such as error handling mechanism and watchdog timers. Lastly, real-time operating system is good at shifting tasks between one another. This approach enables real-time operating system to handle multitasking and concurrent execution of tasks. For the disadvantages, real-time operating system has heavy system resource. It has limited choices in hardware platforms and is very expensive to implement. Next, there is a limited amount of tasks it can support concurrently. It also needs high maintenance due to the device drivers and interrupt signals. This may be quite challenging for developers. Last but not least, real-time operating system has a more complex algorithm due to it not employing many widely used algorithms. I will continue with the pros and cons of multiprocessor operating system. For multiprocessor operating system, it provides reliability and throughput of the processor. With the use of it, one task can be divided among all the processor or multiple tasks be done on separate processor for a shorter processing time overall. Next, it is more economical. It is more worth it to purchase and install one multi-processor system instead of multiple single processor systems. As for its cons, while multi-processor operating system might be economical to deploy, it has a higher upfront cost due to the high maintenance cost. Besides that, it also has a more complex operating system. This is due to the manage multiple processor, distribute tasks, and handle synchronization between processors. Lastly, multi-processor operating system also has a higher system requirement. More hardware and resources need to be allocated for a single system. For example, multi-processor operating system that is executing different processors will need to store more data in the main memory due to having multiple processors running at the same time. That's all for our presentation. Thank you for your time.